Welcome everyone to Knox Game Design for July 2026. My name is Levi Smith. This month we'll be talking about NES 6502 basics. So this month we're going to be doing a demo of a number guessing game in 6502 assembly for the Nintendo Entertainment System. This is going to demonstrate some of these following concepts: generating a random number, displaying text and variables to the screen, user input, handling controller button presses, control statements such as branches, conditionals, and loops, comparing values such as equal, greater, and less than, incrementing value, and game states. So to start out, here's some of the registers for the 6502 microprocessor. We'll be using the accumulator, the X index register, there's also a Y index register, which we won't be using. Stack pointer, we won't be modifying that directly, along with the program counter, but it's good to know that they're there. And then there's a register for the processor status, and it has various different bits for various different statuses, such as carry flag, zero flag, interrupt disabled, decimal mode, break command, overflow flag, and negative flag. And bit 5 is always 1 for the NES. And I always like this diagram right here, which shows all of the opcodes for the 6502 laid out. You just got to remember one opcode can be mapped to more than one machine instruction based on the parameters that it's using. So here's some of the ones that we'll be using. LDA is the load accumulator. STA is store accumulator. We want to store the value that's in the accumulator. We want to store that byte, which is 8 bits, into a memory location. CMP is to compare that accumulator value with another value and then do something based on that, do one of the branch statements based on that. We also have that opcodes that operate on the X register, such as INX, which increments the X register, it just adds 1. STX stores the X register into a memory location, and then CPX is to compare that X register value with another value, then do something based on that, branch to another point in the program. We also have SEI, set interrupt, and RTI, return from interrupt. You'll see this in the NES 6502 assembly. We have CLC for clear carry, which is commonly used with ADC, which is add with carry. Here are those branch statements I was talking about. BEQ, branch on equal. BNE is branch on not equal. BCC is branch on carry clear. And BCS is branch on carry set. So you'll commonly see these used with these compare commands, and it's kind of like if you want to do an if in a programming language, or a loop, a while loop, or any type of loop. That's basically what you'll be using these for. JSR is jump to subroutine. RTS is return from subroutine, just kind of like calling a method in a programming language, and JMP is your jump if you want to jump to a specific point in that assembly code. So yeah, we'll start out in basic game example. We want to generate a random number. So it's a little bit tricky on the NES because the NES doesn't have a clock. In a lot of game development environments, you can seed a random number generator with the current time, which is usually random whenever you start a program, but NES doesn't have a clock, so this is the best alternative I could come up with, which I think is used in other games as well. Basically, you want to set a counter whenever the program starts, and then whenever the user presses start, then it's going to lock in on a value. And since these are incrementing really quickly, then it's somewhat random. So that'd be a good way and that's the way I'm going to be generating a random number in our game here. So yeah, start counter when the program starts, increment on each update, stop when the user presses start. So you got two options. So we want to generate a number from 0 to 100 or 0 to 99. We can keep the secret number stored as a byte and then update the display digits to the screen. That's probably the way you would do it in a typical game. But the problem with this is you must keep the displayed values in sync with that variable. So there's a little bit extra work that you got to do there to take that numeric value and turn it into two displayable numbers for the tens digits and the ones digits. So what I'm going to do is I'm going to track the digits separately. I'm going to have one digit for 10 and one digit for ones and keep those as separate values. This is simpler to implement. The displayed values are the variables, no data redundancy, a little bit of wasted memory space. We've got 8 bits, 0 to 55 for each byte to hold a 4-bit value, because to hold 4 bits, you only need to hold from 0 to 9, and those can be represented with only 4 bits. So we're allocating 8 bits for that. So a little bit of a waste there. And in this example, our digits are going to roll over when they hit 9 and you increment that, then one's going to roll back over to 0, then the tens is going to increment. Or actually, I'm incrementing the tens first, and then as the tens roll over, I'm going to increment 1 just to give more of a random number, because otherwise you're going to get 0 to 99 going up, and you can get a lower number generated that way. But with incrementing the tens first, you can get a more random number. So yeah, here's some of the assembly over here. I'm going to be showing it in Visual Studio Code. But yeah, here's our randomized secret right here. We're going to load into the accumulator our number secret, then we're going to add 1. I guess we could have used the X registered and did an increment X. Then we're going to store that back into number secret. So secret's defined as just a variable at the top. Then we're going to compare that with 10. If it's 10, if it's not 10, we're done. And we're going to jump down to randomized done. Then we want to return from this subroutine. Yeah, so 10 is hexadecimal 0A. Like I said, we're in randomized secret right here. And so if it equals 10, then for the tens value, our num secret 1, we're going to return it back down to 0 by loading 0 into our accumulator and storing that in num secret 1. Then we're going to load num secret 2, going to add 1 to that, and then store it in num secret 2. The num secret 2 is 10. If it's not equal to 10, then we're going to be done and return to subroutine. Otherwise, we're going to set it back down to 0 as well. Yeah, so here's the code right here. Like I said, using the template from the Nerdy Nights example, so there's a link to that source code right there. But I did my number guessing game customization. So I got a game state, num secret 1, number secret 2, number guess 1, number guess 2, number guess count, and then the button state. So I got a title state and a guess state. And here's the boilerplate right there. So here's where we're going to jump forever. Here's our non-maskable interrupt. So this is kind of like where it starts on every, like you can consider this to be your kind of like an update right here. So we're going to draw the score, draw the values to the screen right here. Read controller. And here's our game engine start right here. So we're going to load game state. Compare that to 0. So if it's equal to 0, then we're going to jump down to engine title. If it's equal to 1, we're going to jump to engine input 1. Then we've got an engine input 2 as well. And then after that, it's just return to interrupt. So here's their title. So JSR, we're going to jump down to randomized secret. And this is what I was showing on the slide. Randomized secret. Same code. I already went over all of this right here for generating the random number. Yeah, so we've read the controller right here, basic NES controller. That stores the controller state into buttons 1. So we're going to load button 1 into the accumulator. Then we're going to compare that to 1, 0, which I believe is 16 in hexadecimal, which is the start button. So if it's not equal to the start button, then we're going to go down to game engine done. Yeah, game engine done right here, which is right above our return to interrupt from interrupt. But if it does equal the start button, then we're going to load 1 into the accumulator and save that as the game state. Then we're going to jump to game engine done. So the same values that I defined for the states up here, the variables, state title and state guess. For some reason, I couldn't get these labels to work on the compares, which would have made the source code a little bit easier to read, but I couldn't get that working for some reason. But I'm using the old NES ASM, type build dot bat. Yeah, so NES ASM, got the latest version of that. Using the same thing that I used for the talk last month for the NES photographics, nesasm.exe. It's just going to create an NES file. Yeah, so I'm going to be using FCEUX. So file open. Here's numguess00. So I got each of these built into a different stage. So here's our random number generated right here. I'll zoom in on it right there. Actually, it goes a lot faster than that little preview on the magnifier right there. But yeah, if you hover over and I got my, I'm going to use a PlayStation controller, but you press start and it lands on a number. So press reset, press start. Hey, I land on 00. What is the chances of that happening? Press start, 37. So that's how I'm generating a random number for our number guessing game. So the next step is to input a guessed number. I got 3 states: enter the first digit, enter the second digit, and check answer. You must track the previous and next controller state. Make sure you check when the button is pressed down because you don't want it to continuously register. Increment the current digit value on the D-pad up pressed on current, and D-pad pressed up on previous. So you're basically checking the previous up state and the new up state. So that way, whenever you press up, it's only going to increment one time and not continuously increment that value on every update. Then you can press A to move to the next state. So you press A to go from enter the first number, then enter the second number, then to the check state. So here it is right here, game engine, load game state. Here's our input 1. I already had that in the first demo. Let's take a look at the source code. Yeah, so here's numguess01. So here's engine input 1 right here, button state previous, game engine done. Here's if you press 1, we're going to load into buttons 1, compare that to 80, which is 128. Decimal value for the A button. Branch not equivalent, you're going to be done. Otherwise, we're going to go to the second game state, which is the second number input. Engine input 1 up button. So this is when you're pressing up for the first digit. Up 1 done. Going to add 1 if the up button has been pressed on that update. Store that in number guess. So if it's equal to 10, remember $0 hexadecimal equals 10, then we're going to loop it back down to 0 and then store that in numguess1. Then we're going to jump to game engine done. Engine input 2. So basically we're doing the same thing here. Getting the button state. If they press A, then we're going to the check state, which is 03. Store that in game state. If you pressed up, then we're going to increment the ones digit, and then game engine done. Engine input 3. Basically doing the same thing. We're just not checking it right now. So let's take a look at the example. So now we press start. Got 85. So now we can press up to increment our value. Don't have down working, just up. But you notice as it goes over 9, then it goes back down to 0. So I pressed A. Now we're entering our ones value. 38. There we go. And then after the check state, then it goes back to the input state again. So you can pick a new number. So the point of the game is you keep picking numbers until you get the correct number. Okay, so the next step is adding a cursor so you know which number you're actually entering, or let the player know which number they're entering, and then check to see if that's the correct value. So draw the cursor based on the current digit input. Display message on number check. And then I wrote that program stir to NES to generate message strings. So yeah, like right here we got check. We wanted to display check to the screen. So that program stir to NES will generate the values needed for that. And I guess I will mention, like if we went back, we could probably do this in a subroutine right here. So we have one set of code checking for up presses and start button and things like that. But yeah, right here is our engine input 3. So we're getting previous value for the controller. Buttons 1, checking to see if the A button's pressed. So yeah, it's just going to loop back to let the player enter a new number. Yeah, so we'll mention right here is where we have the different strings, like where it says press start. That's where this is defined right here. Generate secret number. That string's right there. Guess numbers right there. And the word check is right here. Yeah, so I have Python and MSys2, so I can do Python stir to NESPY. So enter a string and type in hello. So that's going to generate the string for hello right there. Then I can put that in my NES assembly, or I can do the word check like that. So this should be the same as check in our assembly down here. If you bring them up side by side. Yeah, 0C11, 0E, 0C14. And you can watch the video about the NES graphics, but these are basically tiles in your tile map. So if your numbers don't start out, if your letters and numbers don't start out at index 0 in your tile map, these will need to be modified. You'll need to add an offset to these. Yeah, so here's numGuess 2. So we've got our random number generating up here. And yeah, I'll go ahead and mention it. This is just for debug right here. So when we're actually, if I was to make this into a real game, you would hide the randomly generated number, but this is just displayed so we can verify that the number that we're entering matches. So you have 5832. So right now it's just saying check. Yeah, it just says check down here. So yeah, it's just showing we're going into the check state after we've entered the number. So yeah, I'm just trying to go step by step, very slowly through this, how I implemented this. So yeah, then the next thing that I did is check the tens digit. Start by just checking one digit, tens digit. We're going to do a CMP, compare value with accumulator, branch to the appropriate label, BEQ for equal. So you can do a BCC for less than, or a BCS for greater than or equal. So we're going to load numGuess 1, compare with number secret 1, going to branch equivalent, display correct, BCC, display higher, BCS, display lower. So yeah, this is kind of the benefit of having the ones digit and the tens digit stored separately. You don't have to extract those out. They're already split between the two. So yeah, so I got the check code right here. I think it's basically in right after the display score. The display method is called, or the display label is jump to. So it's going to fall down here. If we're in game state 03, which is the check state. If we're not in the check state, we're going to go to check done, then return subroutine, return from subroutine. Otherwise, if it is the third state, then we're going to load numberGuess 1, compare that with number secret 1. If it's equivalent, we're going to display correct. We're going to branch to display correct. BCC, if the correct number is higher than your guess, then we're going to display higher. If the correct number is lower than the number you guessed, then we're going to display lower. Yeah, so here's display correct. You're just going to do the standard code for loading to the PPU. We're going to copy the stir correct string. We're going to send that over to the PPUs. We're going to display increment by X each of those characters. Here's the code for displaying higher. And here's the code for displaying lower right there. Here's where higher, lower, and correct, those strings are stored right there. So now I'm going to press start. So I got 84. So I'm going to guess 51. So it says higher. So now press A, and I'm going to guess 94. Then it's going to say lower. I guess 80. It's going to say correct, because we're only checking the first number. That's why it says correct on that one. So the next step is checking the ones digit. If the tens digit is equal, then check the ones digit. If the ones digit check is the same thing to the tens digit. So we got to check tens digit if we're in game state 03. Otherwise, we're going to branch. If we're not in game state 3, then we're going to go to done. Check one's done. Going to load number guess 1, compare it to the number secret 1. So if it's equal, then we're going to check the ones digit. If it's higher, we're going to display higher. If it's lower, we're going to display lower. And then in the check ones digit, we're going to check num guess 2 against num secret 2. Branch unequivalent. We're going to display correct. If it's higher, we're going to say higher, because we've already checked the tens digit. We know the tens digits is equal, so now we're just checking the ones digits. So if it's higher, we're going to display higher. If it's lower, we're going to display lower. Like I said, I mean, the alternative way to do this would have been to store the number in a byte, but then that'd make the comparisons a little bit. It'd make the comparisons here a little bit more easier, I guess. But, well, no, you'd still have to convert both of the display inputs into 1 byte, then compare those 2 bytes. So it'd be a little bit easier on the branch equivalents, but you're still going to have to convert the tens and the ones into one number. Unless you're storing the guess as a byte, but then you're going to have to just convert it into ones and tens on the display. Yeah, and if I didn't mention it before, we do have a section of code here for displaying the cursor. So we've got cursor 1 right there, which is going to get the location of where if the cursor's on the tens digit, it should display it at this location, 2124. Then the cursor is this hexadecimal 28 character, just like a dash. If the cursor is on the second digit, then it's going to be at 2125. And again, it's the dash character. So it's just going to be one row below your guess. And yeah, right after that, we got the checks tens digit. And I showed this on the slide, check tens digit. Then the check ones digit. Right now, you already have this assembled. So let's generate a random number, 15. So I'm going to guess 74. So it's lower. So I press A, guess again, 31, lower. Let's guess 12, higher. Let's guess 14, because I already know what it is. So it's higher. Let's guess 16, lower. Let's guess 15. Correct. So the next step is to add guess count. Need an additional state so that guess check is only performed once. Otherwise, guess will be continually checked. Guess count will continually increase. And I know this because I ran into it and had that guess count. And then whenever you entered your guess, and it kept incrementing the guess count. So yeah, I had to add specific code for only checking once after the guess has been entered. Increment guess count if guess is incorrect. New variable to hold result for display, 0 for correct, 1 for higher, 2 for lower. So we got result correct, load 0, store that into the result. If it's higher, we're going to increment guess count. Got a subroutine for incrementing guess count. We're going to 4. So we got the 4 is actually the state after it's checked. So 4 is like you've checked the number. Now we're waiting for you to do something to enter the next number. Because we don't want to go directly back to entering the tens digit state, because then the player will never see if it's higher or low. I guess you could put it there, but that'd be confusing. You just want to have one state for displaying higher, lower, or correct. So yeah, we got result higher. We're going to store the result, increment the guess count. If it's lower, we're doing the same thing. We're going to use a 2 for the result, increment the guess count, go to state 4, or save 4 in the game state, jump to check done, increment guess count. So basically we're loading into the accumulator the number guess count, we're adding 1, storing that into the number guess count, then returning from subroutine right there. Yeah, so this is the change right here that we're in num guess 5 now. So we got our result higher, result lower for the check ones and tens digits, and then correct if it matches on the ones digit, tens and ones digits, so result correct. We're storing that into result. Got result defined right here. Basically, you just type in the variable you name you want, then .rs1. I think that's for 1 byte. Yeah, so we're going to state 4, saving 4 in the game state, going to check done if it's higher. Yeah, so I explained this on the slides. That's all it's doing right there. Okay, so now we got the guess count right here, guesses. So the same thing, when I press start to generate a number, it stopped on 33. So let's guess 76 lower, and then it incremented the guesses by 1 right there. So now we want to guess 13. So yeah, there we go, 2 higher. Let's guess 40 lower. Let's guess 31 higher. Let's guess 33. Correct. Yay. So yeah, then it just lets you keep on guessing. So really, I didn't get any further than this. But at this point, you would say, hey, game's over, restart the game. Let the player generate a new random number. And then also, as I mentioned earlier, you want to hide the secret number. This is just for debug purposes. But yeah, that's what I would do there. So I actually got this running, put it on the EverDrive. Got a quick little video here. I think it's loaded. Yeah, so this is me going through the demos on the EverDrive. The first one where we're just getting the number generated. It's landed on 6 right there. So you got to press reset every time to get out. So here's num guess 01. So we landed on 36, guessing the number. So this is just that first step of getting where you can input a number. And here's the step where we got the cursor, and then it goes to the check state. And then num guess 03, we got the number generated. And then here's where actually in the check state it says whether it's lower or higher. And here's num guess 04. So here we got the number generated, guessing the number, higher or lower. And that's where it actually detected that the first number is correct. And here's the last step where we got the guess count right there. So guessing higher or lower, and it's incrementing the number of guesses on each guess. So the number is 69, so we guessed 68, which was lower, so it tells us higher. Then we guessed 70, and it told us lower. So then we guessed 69, which was the correct answer, and that's basically it. So I would recommend, like, if anyone wanting to get into NES game development, study up on assembly code and learn your 6502 assembly, and start with a simple game like this number guessing game. Don't try to start out with an RPG or anything like that. Just start out with something simple, guessing numbers. And I guess the next step after this would be like collision detection and figuring out how when two rectangles collide with each other. But I'm not going to get into that this month. So anyway, that's going to be it for Knox Game Design July 2026. Appreciate everyone out there listening and watching.